Hello everyone, welcome to today's video. In today's video, I'll be showing you all certain concepts of R. That is, I'll be discussing with you all the basic portion of R programming. So let's start. First, see over here, I have created a vector named as shapes. Vector is denoted by C. And the vector consists of values like round over long, the values are repeated. So this whole round over long, if you consider this is a set of value, this is repeated 4 times. So there are total 12 values. So I have created a vector called shapes. Vector in R is also called a variable. That is, a vector is a collection of values that has the same data types. Over here, shapes is a character vector that I have created. So see, a character vector named shapes is created with the values which are there. So I have called shapes to check whether the values are properly incorporated there or not. Similarly, I have created another vector called pattern. This is also a character vector which contains pattern, plane, again pattern, again plane. So another character vector is created. I have called pattern. So pattern, plane, again pattern, again plane. Next comes is your shades. Shades is another character vector that we have created, which contains 6 times light followed by 6 times dark. This C is the notation which is used to denote a vector. So another character vector shades is created. And then I have created one numeric vector called counts, containing values 1, 12, 13, 0, 11, 0, 55, 79, 25, 37 and 68. So a numeric vector is created and these are the values of counts. Now I am using the class function. Class function is used to check the data type of the object that you have created. So shapes is a character, pattern also character, shades also character, but counts it's numeric. Next I am incorporating all the vectors, that is shapes, pattern, shades and counts in a data frame. That is, using all the 4 vectors, shapes, pattern, shades and counts, I am forming a data frame and naming it as test. Now a data frame in R is called a data set in R, which has combination of character and numeric variables. Here variables are called columns and rows are called observations. So shapes, pattern, shades are the 3 character variables that are incorporated in the data frame, and counts is another numeric variable that are incorporated in the data frame, which is a data set in R, and I am forming a data set or a data frame in R whose name is test. This is my test data frame. Now let's view test to check how the data frame looks like. See, this is how a data frame or a data set in R looks like. Consists of 4 columns, shapes, patterns, shades and counts. Next, now let's come to the concept of factor. A factor is basically a categorical variable in R. In the newer versions of R, you will find that a categorical variable is never considered as a factor by default. You have to convert that into a factor as per your requirement. In the older versions of R, many categorical variables are by default considered automatically in R as a factor, but in the newer versions, you have to convert that into factor as per your requirement. So see, here I am using the factor function to convert shapes into factor by incorporating the 3 unique values of shapes, because shapes is a categorical variable which has 3 unique values, that is round over long, in the labels keyword. So I have used the labels keyword to incorporate the unique values of shapes, used the shapes and converted that into factor using the factor function and stored it in a object named called shapes factor. So shapes is converted to shapes factor with the unique values round over long using the factor function. And now after converting shapes into factor, the object name has become shapes factor. Now let's check the class of shapes factor. So you see it's a factor. It is converted into factor. Now I am going to incorporate the factor, that is the categorical variable shapes factor, and the vectors, that is pattern, shades and counts, together and form a data frame. I want to name it as test1. I'm using the data.frame function to create the data frame. Data frame, you know, as I told you, it is a data set in R. So if you call test1, the data frame comes in your console window in this way. And if you use the view function, then you get the data frame in its original form. So this is our data frame. Now we'll be learning what is called a rep function in R. Now what is rep function? Rep function stands for repetition. In our previous portions, we have repeatedly typed the value round over long and formed 12 values inside our shapes vector. In order to create the shapes vector, we have to write the values round over long again and again. Right. So in order to avoid writing it repeatedly, that is, in order to avoid doing it in a cumbersome way, we can use the rep function. So I am saying that use the rep function and repeat the set of values round over long 4 times. Again, C is used to create a vector. Here the vector name is shapes1. So shapes1, a character vector named shapes1 is created, where the whole set, that is round over long, is repeated using the rep function 4 times. So let me call shapes1. See, round over long, there the whole set is repeated 4 times and we got altogether 12 values. Similarly, shades1. Shades1, again I am creating using the values light and dark. I am using the repetition function and I am telling R that create a character vector shades1 with the values light and dark, where each value will be repeated 6 times. So here light will be repeated 6 times, followed by dark, which will also be repeated 6 times. So if you call shades1, see light is repeated 6 times, followed by dark 6 times. So you get altogether 12 values. Similarly, pattern 1, again another character vector is created. Using the values pattern and plane, I have used the rep function, where I have used the keyword each equals to 3, 2. That means first each value will be repeated thrice. That is pattern, 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 plane, plane, plane. Then the whole set will be repeated twice. See, each value is repeated thrice. Pattern, 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 plane, plane, plane. Then whole set repeated twice. So altogether we got 12 values. Now I am forming again another data frame named test2, that is a data set, using the vectors shapes1, pattern1, shades1 and curves. So this is my test2 data frame. Now let's do view of test2. So this is my data frame. Now, you might have a question that why I have kept the length of the vectors as 12 for each and every vector. Now, the length of a vector can be anything. But you need to remember vectors are variables, and when you are incorporating that in your data frame, the most important characteristic of a data frame is that the number of observations under each column should be equal. You cannot have a data frame where two columns has, say, one column has 7 observations, another column has 10 observations, another column has 11, another column is 15. That is an unstructured data. That cannot be a data frame. So the most important characteristic of data frame is there should be equal number of observations under each column. The number of observations can be anything, but the values, there should be equal number of observations under each column should be maintained. So here I have kept the number of observations as 12, and I have kept the length of each vector also as 12, so that the number of observations under each column remains constant. That is 12 for every vector, that is for every variable. Now let's do dim of test2. Dim stands for dimensions. So dimensions gives you the number of rows and the number of columns of your data frame. So in your test2 data frame there are 12 observations and 4 columns. Next comes your dim names. Dim names gives you the dimension names. Now in your data frame, the rows do not have any names, so there are only observation numbers. So the row numbers of the observation numbers are displayed from 1 to 12. And your column names are given because you have vector names or variable names. The column names are shapes 1, pattern 1, shades 1 and counts. Now let's come to the concept of STR. STR stands for internal structure of your data. That is how or what are the data types of the variables in your data frame. So how does R considers each and every variable, or what data type does R considers each and every variable inside the data frame. So shapes 1 is considered as a character in your data frame. Test2. Pattern 1 is also considered as a character vector. Shades 1 is also considered as a character vector. Counts is considered as a numeric vector. So this is the internal structure of the data. That is, what are the data types of the variables inside your data frame. Now let's do test2 $shades 1. This is used to extract the column shades 1 to test2 from the test2 data frame. Now this extraction is done in such a way that the value of shades 1 is displayed horizontally. When you use the syntax of $sign to extract a particular column from the data frame, the column is displayed horizontally. Now extraction can be done in multiple number of ways. This is the first way I showed you. Now let's come to the second way. The second way is when you extract using a pair of square brackets and then when you enclose the variable name within quotations. So here I have used a pair of square brackets enclosed shades 1 within quotations. This is also to extract the shades 1 column from the test2 data frame, but here you see when you use a pair of square brackets, the column is displayed vertically. When you use the $sign syntax, it is displayed horizontally. When you use a pair of square brackets, then it is displayed vertically. Now let me check the class of the object test2 $shades 1. That is, when shades 1 is extracted from test2 in a horizontal manner, then what is the data type of that object? We are checking that using class. So that gives you character. So when shades 1 is extracted horizontally from the test2 data frame, we are using the $sign syntax. The class is a character. But when we are extracting shades 1 vertically from the data frame test2 and we are checking the class of it, it gives us a data frame. Why? Because you have noticed that when shades 1 is extracted vertically, it is extracted in form of a column from a test2 data frame. So this looks also like a data frame. This is also a data frame which has 12 observations with 1 column. So the class of that is also a data frame. Now let's come to the sort function. Sort function is used to sort your variable by default in ascending order. Here I am sorting the counts variable in ascending order because counts is my numerical variable. I have applied the sort function for my numerical variable counts, which is sorted in ascending order. Now we are using the summary function. Summary function is also applicable to a variable which is numerical in nature. Summary gives us the 6 statistics of our data or the 6 statistics of our variable. Summary generates the 6 statistics of our variable. So we get the minimum value, the first quartile, the median, the mean, the third quartile and the maximum value. Now next comes the concept of 5num of counts. 5num is also a function which is only applicable for numerical variables. Here I have applied 5num on counts. So 5num gives you Tuckey's 5 number summary, which consists of values, minimum value, this is minimum value, lower hinge, median, upper hinge and maximum value. Now let me explain you on what is lower hinge and upper hinge. Say suppose you have a set of values in a particular variable. It's a numerical variable. First you sort the variable in a particular order. Say I am sorting it in ascending order. So after sorting it in ascending order, if you divide the variable into 2 halves, so you get a lower half and you get upper half. The portion below median is your lower half, the portion above median is your upper half. So the middlemost observation of your lower half is called a lower hinge. The middlemost observation of your upper half is called the upper hinge. So that is about your 5num function and lower hinge and upper hinge. Now I am collecting the column names from my test2 data frame and I am storing it in an object called X. I am using equal to sign. In R you can either use equal to sign which is considered as an assignment operator, or you can use this sign. Equal to sign can be used, or this particular sign is also considered as assignment operator. So whichever is suitable for you, you can use that. So here I have collected the column names from the test2 data frame and stored in an object called X. Similarly, I have collected the row names from the test2 data frame and stored in an object called Y. Now I am collecting I am using the length function to calculate the length of X. So X contains the column names. So there are 4 columns in the test2. So the length of X is 4. Y contains the row names of test2. So there are 12 rows in test2. So the length of Y is 12. Now I am using this object X and Y and forming a list data structure using the list function and storing it in ABC. So I have incorporated X and Y to form a list and stored in an object called ABC. Now let's do view ABC. View it. In order to view a data structure, you have to use the view function. You see, this is how the list looks like. As you know, list is a unstructured form of data from where we cannot draw any specific interpretation. Now I am forming a matrix using the values 1 to 6 with 2 columns. N col equals to 2 means number of columns will be equals to 2. Similarly, so a matrix is formed with the values 1 to 6 with 2 columns. Similarly, I am forming another matrix with the values 1 to 6 with 2 rows. N row is a keyword or a function which is used or which denotes the number of rows. It is used to define the number of rows. I am forming the matrix with the values 1 to 6 with 2 rows. See, a matrix is formed with the values 1 to 6 with 2 rows. Now, I am forming a matrix with the values 1 to 8 with 5 columns and by row equals to true keyword I have used. Now, if you see your matrix, you see the values of your matrix are always arranged in column wise, that is 1, 2, 3, 4, 5, 6. Values inside your matrix are always arranged in column wise by default. Now, when you form a matrix and use the function by row equals to true, then the values will be arranged row wise. So here I am telling R that form a matrix using the values 1 to 8 with 5 columns and arrange all the values inside the matrix row wise. That's why I've used the function by row equals to true, and the matrix will be stored in an object called mat. So let me call mat. So here you see you got a warning message. Why did you get a warning message? Here I am forming a matrix using the values 1 to 8 and my end call is equal to 5. So the number of columns is 5 and the values are 1 to 8. These are not multiple of each other. As they are not multiple of each other, you see you got a warning message. That is the values from 1 to 8. All the values from 1 to 8 got consumed till the third column and the second row. The remaining these two, you do not have any values for the remaining these two blocks. You got a warning message but you got your result. So in order to fill up these two blocks, the first two values of your matrix got again repeated. That is 1, 2. And you have used the keyword by row equals to true. So the values are arranged row wise. Values in a matrix are by default arranged column wise. You see it's like 1, 2, 3, 4, 5, 6. But when you use by row equals to true, it is arranged row wise. It is 1, 2, 3, 4, 5, 6, 7, 8. So from 1 to 8 values got consumed and then again the first two values of your matrix got repeated. Now mat 2, 4. What does this mean? This means from your matrix, you want to display the value corresponding to your second row and fourth column. So if you draw a line, this is a line from second row, this is a line for fourth column. The value which is intersecting these two is the value 1. So in order to display this particular value 1, you have given 2, 4. That is the value coinciding the second row and fourth column is displayed. That is 1. Next, now I am forming an array with values 1 to 32. Then I am again forming an array with values 1 to 32 where the dimensions have given 4, 4, 2. What does this mean? That I am forming an array with the values 1 to 32 with 4 rows and 4 columns and 2 sets. So you see the array is formed with 4 rows and 4 columns and 2 means 2 sets. That is the first set of array is from 1 to 16. The second set of array is from 17 to 32 with 4 rows and 4 columns. Next, this is again a very interesting function. We have done test2 $counts equals to max of test2 $counts. So first the counts variable is extracted from the test2 data frame. So first let me call test2. So this is my test2 data frame. So first my counts variable is extracted from the test2 data frame. So here see the maximum value of my the count. This is my counts column. So this counts column got extracted when we do test2 $counts. Then from using the max function, the maximum value of the counts variable is extracted. So here the maximum value is 70. Now corresponding to the maximum value, the entire observation got displayed. That is 8 oval pattern dark and 70. entire observation got displayed corresponding to the maximum value. Now, instead of max, you could have also used min. In that case, you would have got the entire observation corresponding to the minimum value of counts. Let's move to the next part. Now I want to display the first three values of counts. That's why I have given 1:3. So the first three values of counts got displayed. That is 1, 12 and 13. Now I am telling R to display the first three values, that is first, second, third, and then the 7th, 8th and 9th value. See, the first three values and then 7th, 8th and 9th value got displayed. Let me call pattern 1. Pattern 1 is a character vector that I have created consisting of pattern, plane, 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 again pattern, again plane, plane, plane. Now I am checking which of the values of pattern 1 contains pattern. So that's why I have used this equality operator. I am checking which of the values of pattern 1 contains pattern, and that will be stored in hash pattern. So when you do that, when you are checking that which of the values of pattern 1 contains pattern and you have stored in an object called hash pattern will return the values in form of true or false. So here a logical operation is performed. So whichever values has got pattern, they are replaced by true or they are returned as true. Wherever pattern 1 contains pattern, so those values are true, they are returned as true, and whichever values of pattern 1 has played, those are returned as false. So this is a logical operation I have stored in an object called hash pattern. Now if you do counts of hash pattern, what does this give you? So hash pattern contains what? Hash pattern contains the values of pattern. That is, which of the values of pattern 1 has pattern, hash pattern is checking that. So here only the true values will be considered, that is whichever values of pattern 1 has pattern. Corresponding to those true values, that is corresponding to those pattern values, whatever are the values of your counts will be displayed. So if you check your test2 data frame, corresponding to the pattern values, whatever the values of the counts are displayed, that is 1, 12, 30, 55, 79. Because hash pattern is checking which of the values of pattern 1 contains pattern. So only the true values will be considered. Now hash pattern is a logical operation. If you check the class of hash pattern, it is going to give you the data type as logical. Now again I have done view test2 to view the data from test2. See, it has to have observations with 4 columns, shapes 1, pattern 1, shapes 1 and counts. Now let me call test2 so that I can display test2 in the console. Now corresponding to the hash pattern, I want to extract the second and the fourth column from my test2. So I want to extract values from the second and fourth column of my test2 data frame corresponding to the values of hash pattern. So again hash pattern is going to take the values. A hash pattern is checking which of the values of pattern 1 contains pattern. So wherever it has pattern, it is returning true. So only the true values are going to be considered. That is, only the pattern values are going to be considered because it is checking which of the values of pattern 1 has pattern. So corresponding to the true values or corresponding to the pattern values, whatever values are there in the second and fourth column of your test2 data frame will be displayed. So your second column is pattern 1, fourth column is counts. So pattern, again pattern, again 1, 12, 13, 55, 79 got displayed. So let me run this code. See. All the values corresponding to the hash pattern, that is corresponding to the true values, that is corresponding to the pattern values from the second and fourth column of my test2 data frame got displayed. So all the values from the second and fourth column from the test2 data frame corresponding to the values of hash pattern got displayed. Second column is pattern 1, fourth column is counts. Now let me show you, this is a form of subsetting data. So let me show you another form of subset. Here I have specified the column number. You can do the same thing by specifying column name. That is corresponding to the values of hash pattern. I want to display the values from the column of pattern 1 and counts of my test2 data frame. So you will get the same result. Here I have specified the column names. So all the values of pattern 1 and counts from the test2 data frame corresponding to the hash pattern values got displayed. Next, let's come to the concept of subset. Here I am subsetting data. I am using the subset function. So I want to extract the entire columns of pattern 1 and counts from the test2 data. So when you want to extract more than one column from a particular data set or data frame, you can use the subset function. I am extracting the entire column of pattern 1 and counts from the test2 data frame using the subset function, that is subset test2, select. Select is a keyword to specify the columns which I want to extract from the data frame. So the entire column pattern 1 and counts got extracted. Now we have already done of how to extract two columns from a data frame corresponding to the value of hash pattern. So you can do the same thing using subset function. I have used the subset function. I want to extract pattern 1 and counts from my test2 data frame corresponding to the value of hash pattern. So I have used subset equals to hash pattern. Next, I am extracting the counts column from my test2 data frame. I am using the syntax of a pair of single square brackets within quotations, and counts will be enclosed within quotations. I am extracting counts from the test2 data frame and I am storing it in an object named as XTR. Let me call the object. See, the entire counts column got extracted. It is displayed vertically. When you use this particular syntax, that is within a pair of square brackets and the variable name within quotations, it is displayed vertically. Now let me check the class of test2 open square brackets within quotation shapes 1. That is, when you are extracting shapes 1 from test2 in vertical form, then what is the data type of that object? I am checking that. So here the shapes 1 is extracted from test2 vertically, that is, it is extracted in form of a column. So the class is a data frame. Now this is another way of extracting a column from a data frame, that is, you can use double square brackets and you have to enclose the variable name within quotations. This is another way of extracting. When you use double square brackets with quotations, that is with the variable enclosed in quotations, that time your variable name is displayed horizontally. If you check the class of it, that is the data type of it, when you check the data type of shapes 1, which is displayed horizontally, and shapes 1 is within double square brackets from the test2 data frame, if you check the data type of it, so it's a character. Now let me call the counts vector because we'll be working on that. This is my counts variable or counts vector, which is a numeric one. I am saying counts equals to 0. Again I am using equal to operation. And again I am doing a logical operation to check which of the values of counts are equal to 0. So whichever values are 0, they are returned as true, and the rest of the values are returned as false. So there are two zeros. So see, there are two true values. The rest of the values are non-zero terms. That's why they are returned as false. Now, whichever values of counts are equals to 0, I am replacing them by any. So the zero values, whichever values of counts as zeros, those will be replaced by na. So I have assigned this to na. So if you call counts, you see the zero values got replaced by na and the rest of the values are normal. Now I'm using the is.any counts. That is, I am checking which of the values of your counts has got na. So which is.na is again a logical operation or a logical function. It is going to check which of the values of your variable, that is numerical variable, over here it's counts, has got the values na. So wherever it has the values na, they are returned as true and the rest of the values are false. Now I am storing this logical operation in an object called xyz. This is a logical operation. I'm checking the class of is.na counts. So it's logical. Now I want to replace back the na values by 0. That's why I've done counts of xyz equals to 0. I had stored is.na counts in an object called xyz. Now I'm replacing back the na's by 0 to get my original variable. So now my original variable got displayed where all the na values are replaced as 0. Again here I have extracted pattern 1 from test to data frame horizontally. I have used a $sign syntax, so it will be extracted horizontally. I am checking the class of it. There is a data type of the object when it is displayed, when it is extracted horizontally from the data frame. It's a character. Now I am forming an object called popText, which contains numerical values separated by commas but enclosed within quotations. Since the values are enclosed within quotations, so this will be taken as a character value. Let me check the class of popText. It's a character. If you call popText, see the values got stored inside the popText object. I am using the gsum function to remove all the commas from my popText and form one single value which will be enclosed within quotations, and that will be stored in an object called popNum. See, one single value got stored in popNum, all the commas got removed and it is enclosed within quotations. Now if you again check the class of popNum, it will remain as character because it's still within quotations. Now in order to convert this into a numeric data type, I am using the as.numeric function. So popNum will be converted to numeric data type using as.numeric function, and it will be again stored in popNum itself. So if you check the class of popNum, you see it's numeric, and now if you call popNum, it's one number. Now another numeric vector is created, that is rating. You know numeric vectors are created using the notation C. Contains value 100, 101, 100, 101, 100, 200, 200, 100, 102. These are the values. So I have created one numeric vector called rating. Let me check the class of it. It's a numeric one. Now I have already shown you how to convert a vector into factor. We have done one syntax, that is using the factor function. You can also use the function as.factor. I am using the as.factor to convert the rating into factor data type, and I am storing it in rating itself. If you check the class of rating, it is a factor. Now let's come to the attributes function. Attributes of a data frame gives you the data description of the data frame. So that is the names. Names means the column names of your data frame got displayed: shapes 1, pattern 1, shapes 1 and counts. So this test2 data frame has the 4 columns, and these are the column names. The class of your data structure, these attributes you are checking, so it's a data frame. And the row names. In your data frame you do not have any observation names, so the row numbers got displayed. Now attr function is a sub-function of attributes. Now suppose if you want to display a particular attribute from the data frame, you can specify that attribute name within quotations. So here I have specified it as names. So instead of names, if you could have given class, you could have given row.names, then that particular attribute would have been displayed. So here names I have displayed, Names are specified, so the column names of the test data frame got displayed. Because names, this particular attribute stands for column names. Now let's do XTabs. XTabs stands for cross tabulation. So I am doing cross tabulation with the three categorical variables which are not considered as categorical variables in AND view of the converter. But you know these three are categorical variables, you can say, because they have some unique values. That is, I am doing extra cross tabulation with shapes1, pattern1 with respect to counts, and I am accessing these variables from the data that is tested. See, when you do this cross tabulation, first the last variable which is given, that is pattern 1. So now your entire data is divided into two parts. Your pattern 1 has two categories, one is pattern and another is plane. That is pattern 1 equals to pattern 1 equals to plane. So the entire data got divided into two parts. Now, wherever your pattern 1 contains pattern, that is the values where pattern 1 contains pattern, the bifurcation will be done with respect to shades 1 and shades 1. Shades 1 has two types of values, dark and light. Shades 1 has long, oval and round. So if you just, let me call the test2 data frame. This is my test2 data. So the first bifurcations, as I told you, it is pattern and plane. These are pattern and these are plane. Wherever your pattern 1 is equals to pattern, how many dark long, how many dark oval, how many dark round, light long, light oval, light round is given. So let us view the data frame. So wherever values of pattern is there, light round is 1. Again, do you have a light round? Again, light round is 0. Wherever the pattern 1 equals to pattern. So light round, wherever your pattern 1 equals to pattern, the counts is equals to 1. So if you check the XTabs, light round, it has 1. Similarly, in this way, dark long, if you check, for pattern 1 equals to pattern, dark long, is 9. So see, this is 9. In this way, you got again for pattern 1 equals to plane. So wherever the values of pattern 1 equals to plane, within that again a bifurcation is done between shades 1 and shades 1. So the count value of dark long, dark oval, dark round. If you have multiple observations with dark long, with pattern 1, with the pattern 1 equals to plane, so the counts values gets added in that case. Dark long, the count of dark oval, the count of dark round, light oval, light long, light oval, light round are displayed. Always remember that the bifurcation is done first with respect to the last column which was specified, and then the cross tabulation is done with respect to the remaining two variables. So this is about your XTabs. Now I am creating an object named deadline, which contains 1990-12-01. So this is a date which I have enclosed within quotations. I have checked the class of deadline. Now using the as.date function, I am converting this particular date into date data type. So if you check again the class of deadline, it is a date data type. Now if you call deadline this is the date. Now I am storing the system date in an object called today. I am creating an object called today where I am storing the system date. So my system date is 11 September 2023. That got stored in today. Now I am doing today minus deadline to find the number of days difference between today, that which contains system date, and the deadline which I had created before. So your deadline is 1990-12-01. So between the date 2023, there is between the date 11 September 2023 and 1st December 1990, whatever days difference is there, I am calculating the days difference using today minus deadline between the 2 dates. That is between 11 September 2023 and 1st December 1990, the days difference are displayed using today minus deadline. So the time difference is 11,972 days. Here the date difference you get in terms of number of days. Now let's come to the head function. Head is a function which gives you the first 6 values of your data frame. So test 2 has got 12 observations. Out of them, the first 6 values got displayed. Tail is a function which gives you the bottom 6 values. So your data frame again has got 12 observations. The last 6 values got displayed, that is 7, 8, 9, 10, 11, 12. That is the last 6 values got displayed. Now you want to extract the first 5 observations from the test 2 data frame. So you are given head test 2, 5. So the first 5 observations of test 2 data frame will be displayed. So the first 5 observations of the test 2 data frame got displayed. Similarly, as being number of observations you want to display, you can specify. Here I want to display the first 10 observations of the test 2 data frame. So you will get the first 10 observations of the test 2 data frame. Next, this is again a very interesting function. Here I have combined head and tail together. So first I have extracted the bottom 6 observations from the test 2 data frame using the tail, and then using the head 3 function I have extracted the top 3 observations from the bottom 6. So first the bottom 6 observations got extracted from the test 2 data frame. From the bottom 6 the top 3 observations got extracted using head 3. So the bottom 6 observations are, if you see the test 2 data frame, let me call the test 2 data frame. So this is your test 2 data frame. First, when I say the bottom 6 observations got extracted, that is 7th, 8th, 9th, 10th, 11th, 12th. From the bottom 6, when you use tail, test 2, 6 is going to extract the bottom 6. And from there, on that, when you apply head, 3, so from the bottom 6, again the top 3 got extracted, that is 7th, 8th, and 9th. So if you run this code again, you see the top 3 observations from the bottom 6 observations got extracted. Now I am using the ST function. ST stands for standard deviation. I am extracting the counts column from the test 2 data frame and calculating the standard deviation of it. You know, standard deviation is a function which is applicable only for numeric variables. So the standard deviations of the counts variable present in test 2 is displayed. Now I am using another function called paste. Paste is used to join. So I am joining. I have used a sum function to calculate the sum total of the counts variable. So the sum value will be displayed, again that will be joined with candies. So the total value of the counts variable present in test 2 is 301. and that I have incorporated in a sentence that is there are the sum 301 and then candies. So for joining I have used the test function. For joining I have used the paste function. Now I will show you how to import your raw data file. Here I am importing a notepad file. In order to import the notepad file, I have used the function read.table. File equals to, I have given the path where my raw data file is present. So here my raw data file is present. Here, see test4. You can just right click on it, on the raw data file wherever you save it. Go to properties and take the path from here. Or take the location from here. If you copy the location, you see here the location is coming as single slash. But in R, single slashes are not applicable. You have to use double slashes. I have given the location. I have given the file name, that is test4.extension will be text because it's a notepad file. I have enclosed them within quotations, comma, header equals to false, that means I do not want column headings, and then separator equals to within quotations I have given some space. That is the original raw data file, that is your notepad file is separated by space, that is your delimiter. So let me run this code. Test4 got executed. Let me do view test4. So this is your raw data file or notepad file which got imported into R, and this is how it looks like. You do not want the column headings, so the column headings has come as variable 1, variable 2, v3, v4, v5, v6. V means variable. Now I am activating this particular library for it. Now first, when you have to use a particular library, you need to check that whether that library is present in your package list or not. So this is your foreign library, this which is already present. If it is not present, if a particular library is not present, you have to go to your install option on the package. You have to write the name of the library. You will get it in the drop down. You can select from there and then go to install. You should have a proper internet connection for that. So I am activating this particular library by using the library function and then the library name. Now this particular foreign library is necessary. Why? Because I want to import one SPSS file. This SPSS file name is KFC. The extension is .sab. Again I will take the path. The KFC file is present over here. You can just click over here, go to properties, right click, and then you have to copy the location from here. In this case also location is going to come as single slashes, you have to use double slashes, and then the file name. Last you have to give the original file name, .sab is the extension, including within quotations. I am using the function read.spss to import the SPSS file, and after importing the SPSS file or the SPSS raw data file into R as a data frame, I am storing it in an object name called credit. So credit will be the name of my data frame after importing the SPSS file. So let me view credit. See, the SPSS file got imported in this way. Let me check the class of it. It's a list. Now I'll show you how to import a SAS dataset. To import a SAS dataset, you need again a library called SAS7BDAT. So I will check whether this library is present in my list or not. This is present. And you need to know something that SAS7BDAT is generally not a system inbuilt library. That is, when you install R on RStudio, SAS7BDAT doesn't come automatically with it. It's not a system inbuilt library. It is a user inbuilt library, you need to install it. I had already installed it over here, but in your cases you will not be getting the library installed by default or automatically. You need to install it. What do? You have to go to the install option, write SAS 7 bdat, and then just go to the install and it will be installed. So I am using the library function to activate this particular library, and now I am using the function read.sas7bdat to import the SAS dataset. That is file equals to, within quotations I've given the path. My file name is CandyCL summary. Extension will be .sas7bdat. The path is totally within quotations and I've used double slashes. My file is present over here. CandyCL summary.sas7bdat. I can go to properties. You can copy the location from here after right-clicking on the file. After you copy the location, it will be coming as single slashes. You have to use double slashes. So I am importing the SAS dataset into R and storing in an object called credit1. So SAS dataset, after getting imported to R, the dataset name will be credit1. Then I am viewing it. So SAS dataset got imported. You see, CandyCL summary.sas7bdat is a SAS dataset which got imported into R. Whose name I have given as credit1. Now, state.name is a inbuilt data structure. In R, I am calling that. It contains names of different states. Contains names of different states, you see. Names of different states are there. Now I am going to apply the sapply function, that is apply function, in the state.name data structure, and I am using toOpper. toOpper is a keyword to convert the words into uppercase. And what does sapply function do? sapply or sapply function is going to return the data structure in form of a vector or a matrix. So I want to return the data structure in form of a vector or matrix. That's why I'm using the sapply function, and I have stored in an object name called stated. After converting it, or after returning the data structure in form of vector or matrix and applying the toOpper keyword to convert the words into uppercase, I've stored it in an object name called stated. So if you call stated, see, the state names are there, the original names are given, and then after it is converted into uppercase using the toOpper keyword, that is also for all states, it is applied. If you check the class of stated, it is a character. Now stated is now converted into a vector form because sapply function converts the data structure. Like whichever data structure you are applying the particular sapply function, is going to be converted into a vector data type, and toOpper is used to convert the words into uppercase. Now I am using the lapply function, that is lapply function on my state.name data structure. Again I have used toOpper function. Lapply is going to convert the state.name data structure into a list, and toOpper is going to convert the words into uppercase. So after converting state.name into a list data structure with the words in uppercase using the toOpper keyword, I have stored it in an object name called stating1. So this is stating1. So the words are converted into uppercase. All the state names, words are converted into uppercase. Next, if you do view of stating1, you see. This is how a list data structure looks like. If you check the class of it, it's a list because it is converted into a list data structure. Now I'm forming a matrix using the values 1 to 10 with 3 rows and 3 columns. N rows stands for number of rows, N columns stands for number of columns, and I'm storing the matrix in an object called X. Here you got a warning message again. Why? Because the values are 1 to 10 and we said 3 rows and 3 columns. They are not multiple of each other. So you got the warning message. Like for 3 rows and 3 columns, the values are consumed from 1 to 9. That is, the value 10 is missing in your X matrix because they do not have space to accommodate the last value, that's the value 10. So you got the warning message because they are not multiple of each other, that's why they couldn't accommodate the value 10. If you check the class of X, so it's a matrix or an array. Now I'm using the apply function on the matrix. So I'm using the apply function. Apply is applicable on the dimension of the matrix. So I'm using the apply function on the matrix whose name is X. And I'm calculating the sum. Now, here when I give 1 and 2, 1 and 2, these denotes dimensions. So when I am saying X comma 1 comma sum, so they are going to calculate the row sum because 1 denotes row and 2 denotes column. So when I am doing apply X comma 2 comma sum, so it's going to give me the column sum of the matrix X. Similarly, X comma 2 comma mean is going to give you the column mean. 2 comma SD, if you do X comma 2 comma SD, it will give you the column SD. X comma 2 comma median is going to give you the column median. So you can calculate any value, sum, mean, SD, median of either the row or the column of the matrix, where the row denotes 1 and the column is denoted by 2. So dim equals to 1 means row, dim equals to 2 means column. Dim stands for dimension. Now I'm going to show you all how to create your own function. Here I'm creating a function called commission, which is a function of sales. I have given 4 level of interests, that is T1, T2, T3, T4. T1 is 8%, T2 is 9%, T3 is 0.105 and T4 is 12%. Now I am saying if my sales value is between 0 to 50,000, then the commission will be sales into T1. That is, sales value between 0 to 50,000, 8% level of interest will be applicable to calculate commission. If your sales value is between 50,000 to 1 lakh, then 9% level of interest will be applicable, that is sales into T2, in order to calculate commission. If your sales value is between 1 lakh to 2 lakh, then 0.105 level of interest, as rate of interest will be applicable to calculate commission. And if your sales value is beyond this range, that is above 2 lakhs, then 12% level of interest will be applicable. Now I am using different level of sales values. I am applying different values of sales to calculate the commission function. First I have applied the value as 10,000. So here the T1 level of interest is applicable when you do 75,000. T2 level of interest is applicable because it is between 50 to 1 lakh, the ranges. And when you apply, and again I have used the value 1,50,000 of sales, that is third range. The third range of value is applicable. So T3 level of interest is applicable. Now again I am creating a numeric vector called M cells, which contains values 10,000, 80,000, 1,40,000 and 90,000, 97,000. A numeric vector is created and I have named it as M cells. I am applying the commission function on the M cells vector. Since M cells is a numeric vector, I am using the sapply function because sapply function converts the data structure into vector. So after applying the value, or after applying the function commission on the M cells vector, the values will be returned in form of a vector only. So in order to return the values in form of vector data structure, I have used the sapply function stored in an object called M. You see, the commission is calculated for all the values of sales present in the M cells vector. have created one numeric vector called fellows1, then to1, and then to2. And then I'm using the rbind function. Rbind stands for row bind, to combine all the three vectors fellows1, to1, and to2. Fellows1, to1, and to2. I'm combining all these three rows and forming a data structure and named it as lot1. So lot1 is formed. Now if you check, lot1 is formed by combining the three rows fellows1, to1, to2. They are considered as rows because I have done rbind. I have done class of lot1. So if you check the data type of the object lot1, so it is a matrix and an add. So when you are doing rbind, when you are using the rbind function over here, I have combined three rows fellows1, to1, to2, which are the three numeric vectors. I have combined them in form of rows using rbind, and a matrix called lot1 is created. Next, now I am giving some column names to my matrix lot1. I have given the column names as US, non-US, and I have given the row names as fellowship, 2 towers, and return king. Column names are given using the function call names, and row names are given using the function row names. So if you call lot1 now, the column names and the row names in your matrix got incorporated. Next, I am doing certain matrix operations. I am dividing each of the values of the matrix by 1.12. This is normal matrix division. Now I have done data USA arrests. I am loading the dataset USA arrests. I am doing viewed USA arrests. This is my inbuilt dataset USA arrests in R. Now what I am doing, I am forming a column called Z inside my USA arrest dataset, which is 2 times of the rape variable in the USA arrest dataset. So the column Z is formed, which is twice of the rape column. Now let me do view USA arrests. I have viewed it. Viewed the data frame. Now I am extracting the row names of USA arrests, and I have stored in an object called state. So the row names of USA arrests got extracted. And I have inputted it. Okay, so I have created a column called Z, which is twice of the variable rape present in the USA arrest dataset, and then I have called USA arrests. See the column Z is formed, which is twice of rape. Now you can also view USA arrest. To view it in form of a data frame, the Z column is formed, twice of rape. Next, I am extracting the row names of USA arrests and I am storing it in an object called state. Then I am extracting murder column from USA arrest and storing in an object name called murder. Now I am doing cbind.data.frame, that is, I am combining state and murder in form of columns and forming a data frame, named it as crime. So if you view crime, you see state and murder, 2 columns are formed. If you check the class of crime, so let me check the class of crime first. If you check the class of crime, it's a data.frame. Now again I am combining state and murder together in form of columns using cbind. Here I formed a data frame. I have combined them in form of columns and formed a data frame. So I have used cbind.data.frame. Here I am doing normal column bind. I am combining both of them in form of columns and forming a data structure called crime1. On viewing crime1, the two columns got combined and crime1 is formed. Let me check the class of crime1. Now crime1 is a matrix or an array data structure. So when you do cbind.data.frame, then a data frame is formed. But when you do normal cbind, then a matrix or an array is formed. Now again I have created one character vector called shapes consisting of values round over long, round over long, round over long, round over long. There are 12 values. Similarly, pattern, another character vector I have created pattern, 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 plain, 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 pattern, 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 plain, plain, plain. I have created another character vector that is total. All total I have created 3 character vectors. Shapes, pattern, then shades with 6 times light followed by 6 times dark. Then I have created another numeric vector called counts. I have formed the test2 data frame by incorporating shapes, pattern, shades and counts. I have viewed test2. So the test2 data frame is formed. Again I have created another vector called shapes with values circle, rectangle, square, circle, rectangle, square, circle, rectangle, square and circle, rectangle, square. There are 12 values. Pattern I have created with 6 times rough and 6 times smooth. Another character vector. Shades I have created 6 times pink and 6 times dark. So 3 character vectors, shapes, pattern and shades and counts, another numeric vector I have created. Now I have created a data frame called Choco, which consists of the second set of shapes, pattern, shades and counts. So I have done view Choco. You see it consists of the second set of vectors, shapes, pattern, shades and counts. 3 character vectors and 1 numeric vector. Now I am doing R-bind, that is I am combining the data frame test2 and the data frame Choco in form of rows, that is R-bind, and I am forming a data structure called dot. So let's do view dot. If you do view dot, see there will be 24 observations. 12 observations from the first set of data frame, that is from test2, and 12 observations from Choco. All got combined in form of rows and dot is formed. Now I am doing class of dot. Since 2 data frames are combined in form of rows, so the resulting data structure which is formed dot, that is also a data frame. So class of dot is a data frame. Now let's check the range of counts. Counts variable range function is going to give the minimum and the maximum value. That is, minimum is 0 and maximum is 97. Now I am saying attach empty cars. Now attach is a function. When you empty cars is an inbuilt data set of R. Now what is the attach function? Attach function, when you use the attach function in R, that means you are telling R that from now onwards I am going to work upon this particular data frame or a data set. So instead of referring to the data frame again and again in the code, you have done attach. That means you are telling R that I am going to function, or I am going to perform all the functions, all the instructions, whatever I give to R, it will be based on that particular data frame only. So automatically R is going to access the data frame. Data empty cards is used to load the data set. View empty cards, this is a motor trend card test data set consisting of different car models. Their MPG, miles per gallon, number of cylinders, displacement, horsepower, rear axle ratio, weight, quantity second versus aim, number of gears, number of carburetors, all these things are displayed. So it's a motor car test data set. Now what I want to do, I have shown you a couple of ways of how to subset data. This is another way. That is from the empty cards data frame, I want to extract the first column and then the 5th, 6th and 7th column, and I want to store in an object called new data. Similarly, this is how you extract the columns from a data frame by specifying the column numbers. Here I have specified the column names. If you call new data, the first column and then the 5th, 6th and 7th column got extracted. So that is subsetted data. First column is MPG, 5th, 6th and 7th column is number of reaction ratio, weight, 1 seconds. This is 5th, 6th and 7th column. Next, now I want to subset the data by specifying the column names. That is, I want to extract the MPG column and the HP column from the empty cards data set, and I have stored it in an object called new data 1. Now, let me call new data 1 to see the MPG and HP, that is horsepower, these two columns got extracted. Again, I have executed the function attach empty cards. This is my empty cards data set. Now I want to sort the empty cards data set using the order function. I want to sort the MPG variable, that is miles per gallon variable, from the empty cards data set using the order function in ascending order. So by default, sorting is done in ascending order. I am sorting the MPG variable from the empty cards data set in ascending order. I have used the order function, and I have stored the whole setup in an object called new data. So see, if you see new data, here my MPG variable is sorted in ascending order. Now I want to sort the MPG variable from the empty cards data set in descending order, and I have stored it in an object called new data 3. So in order to sort a particular variable in descending order, we have to use the minus sign before the variable. MPG is sorted in descending order and it is stored in new data 3. I am sorting it and storing it in a different object so that my original data set remains intact. So if you sort it, so this is sorted in descending order. Now again I am sorting the empty cards. I am sorting the empty cards data set with respect to two variables, MPG and number of cylinders, that is MPG and SIL, in ascending order. Nothing is mentioned for ascending order by default, and the whole setup is stored in again new data 2. It is sorted with respect to two variables. That is also in ascending order. So here I have sorted with respect to MPG and number of cylinders in ascending order. Nothing is mentioned, so it will be done in ascending orders and stored in an object name called new data 2. So MPG and cylinders are sorted in ascending order. That is from small to big. Now I want to sort empty cards with respect to MPG and cylinders again. MPG will be in ascending order and cylinders will be in descending order. So I have used the minus sign before the cylinder and I have stored in an object called new data. You see, MPG is in ascending order and number of cylinders is in descending order, and I have stored in an object called new data. So this is all about your the concepts of basic R, or how you work in R. So I have shown you all the concepts of the basic R programming. This will be very much helpful for you all for preparing your data, for doing data manipulation, for subsetting data, and prepare a structured data set which is ready for your analysis. So thank you everyone. This is all about your basic program.